Okay. Okay. Hello, everyone, and welcome. We're running a little bit late. There's a little bit delay, I think, but luckily my presentation is quite short, so I'll be mitigating that delay and saving the conference. So now we will be talking about a zero-day vulnerability in Rsync. And I'm sure most of you are already familiar with this Rsync tool. And we will see some ways of exploiting this vulnerability. But before I start, let me just quickly introduce myself. So my name is BALCI, and I'm the Threat Intelligence Division Lead in PRODAFT. And PRODAFT is a Switzerland-based cybersecurity company that mainly focuses on threat intelligence. Some of you may have heard of our previous reports in the TI field, maybe. We kind of have this like a theme with our reports. We like to analyze the underlying infrastructure of big cybercrime groups. And our reports often expose a lot of unknown details about those big cybercrime groups. And we also do a lot of vulnerability research. So if you're interested in finding 0 days or writing exploits, I highly encourage you to check out our company blog. We release around 10 to 15 zero-day vulnerabilities per year. And as I said in the beginning, our main focus is on threat intelligence. So that's why we kind of pay some extra attention to a certain list of softwares and tools, such as these, because these are mostly used by threat actors. So as you can see, most of the tools are privacy-oriented tools, and some of them are very common and generic system administration tools, file transfer tools such as Rsync, which will be the topic of today. So Rsync is a very fundamental software. There are a lot of other softwares that's built on top of Rsync utility, such as back-in-time, backup assist, and grsync, and especially rclone. Especially rclone is a very popular tool amongst ransomware operators. We ourselves, during our investigations, came across this tool being used for exfiltrating victim data and all kinds of crime-related stuff. So you could say that's the main reason why we started started looking for vulnerabilities in the Rsync utility. So for those of you who don't know what Rsync is, let me just quickly explain. Rsync is a file transfer tool. It's very similar with the SCP utility, the secure copy utility. And the official description is, Rsync is a utility for efficiently transferring and synchronizing files between two storage mediums over networks. So it's released in 1996, so it's 25 years old today. You could say it's quite old utility. And it's also a very popular utility. It's on the 112th place on the Ubuntu popularity contest. So this means it's the 112th most downloaded APT package. And this is how you use Rsync. You just pass a couple of parameters. It expects at least two path arguments, a source destination and the target destination. So then it simply copies the files. So now I'll try to explain how Rsync is working behind the scenes. So in this case, we are copying the entire contents of a remote server to our local destination directory. Once you initiate this file copy procedure, the Rsync establishes a SSH connection with the remote server. And after establishing that SSH connection, you will see this new process pop up on the server side. So if you look at it, it's the exact same binary. It's the Rsync binary. So it executes itself on the remote server with some special parameters. Based on the manual description, these parameters, the options server and sender, are used internally by Rsync and should never be typed by a user under normal circumstances. So those are special parameters that specify the running condition. And you also see this path, the target directory argument at the end. This is the exact same argument you pass on the client side. So once rsync initiates itself on the server side, it starts crawling the target directory. And it crawls the target directory for creating this file transfer list. This file transfer list contains a lot of information about the files that needs to be transferred, such as absolute paths, sizes, permissions, modification dates, and even checksums. So after creating this list, the server sends the list to the client side, and then client simply begins fetching files one by one. During the data transfer process, Rsync uses a special algorithm for making it more efficient. This algorithm is called delta transfer algorithm. It's quite complex, actually. You can read it yourself. The description is very good on their website. But the main purpose of this algorithm is calculating the differentiating blocks between files. So, as I said, it's created for increasing the efficiency of the data transfer. So it calculates a diff between the files, and it only sends the differentiating blocks over the network. So it makes it much more efficient. Of course, if you are copying a brand new file to your system, then it needs to send the entire contents. In that case, it's not much very different with the SCP utility. So this is how Rsync is working in a nutshell. And if you look at the design of this tool, you kind of realize there is this fundamental problem. There's this fundamental and universal issue. If you're copying a directory from a remote server to your local destination, the client doesn't really know how many files to expect. So if the remote host is compromised by an attacker, then the attacker can simply send some additional unwanted files. In this case, we're copying the user directory to our local directory, but client simply doesn't know how many files under the user directory on the remote server. So this is a very fundamental and, as I said, universal issue. It doesn't matter which file transfer application you use. This is always the case. By its own, it's not the vulnerability. It's not a vulnerability, but the vulnerability part begins if the file transfer application is unable to sufficiently handle those additional unwanted files. So for our case, we will try to send some malicious files, additional malicious files, and we will try to overwrite certain files on the client side for achieving code execution. So this attack vector actually is has been researched. There's a very good research done by a security researcher from F-Secure. In 2019, they also found a very similar vulnerability in the SCP utility. Well, the vulnerable code is not the same, but the used attack vector is exactly the same. We will also, they also try to overwrite certain files on the client side for achieving code execution. So we will also doing the same. And these list of files are very critical files. If you're able to manipulate any of these files, then in theory, you can gain access to that server. You can either add a new user to the system, or you can execute arbitrary shell commands. You can add new SSH keys. This is a very simple sublist of files. Of course, there are more critical files that's not in here. But as you can guess, most of the files under the etc directory require special permissions. You need to be root in order to overwrite them, manipulate them. But there are files that the user can access, such as bash rc, zsh rc, those rc files, aliases, profile files, and git config, for example. So we directly started out by pulling the source of rsync. It's available on GitHub, and also you can use the apt source rsync command for fetching the latest available version for your distribution. And since we know exactly what we're looking for, we went directly to the point which is responsible for creating the file transfer list. So this function gets executed on the server side. It takes the argument vector that's passed to the rsync binary and creates the file transfer list I just mentioned a couple of slides ago. So after creating this list, as I said, server sends this list to the client side, and this code gets executed on the client side. It first expands the list and then starts receiving files by calling the receive file entry function. So our goal is to inject our own malicious file entries to that list. So we created our own inject files function that takes the argument vector and adds our own malicious file path. And then we pass the new argument vector to the send file list function. But during our research, we saw that there are some mitigations against these kind of attacks. So you can't write files to arbitrary locations. There are some preventive measures, such as this function called sanitize path. And as the name suggests, it sanitizes the given file path. So you can't use any .. for escaping from the module stop directory. So let me give you an example. If the client is copying this backup.tar.gzip file under the backups directory, then thanks to this sanitize path function, the attacker server, the malicious server, can't send any files, can't write any files under the directories that are above the destination directory. So you can't write under downloads, under users, or you can't write under home. But Rsync allows you to write any file, overwrite any file in and under the destination directory. So if the user is copying a backup.tar.gzip file under its own home directory, then you can simply overwrite the bash rc file or the profile file or any file that's under that directory. So this, as you can guess, this creates the code execution possibility. So we were able to create a POC for this, and I'll just show you a demo video because I don't trust myself. And in this video, at the left-hand side, we have our attacker host, our compromised host, which contains the malicious rsync binary. And at the left-hand side, we have our victim. So victim will be pulling a single file from the attacker host. Currently, we're installing the backdoored version of the rsync binary to the attacker host. And our objective is to receive a reverse shell connection from the victim. So we just installed the backdoored rsync binary to the system. And now we're setting up a netcat listener for receiving the incoming shell connection. So now the victim will pull a single file to its own home directory. So after pulling that single file, we replace the bash rc file from the victim side. And when the victim opens a new terminal tab, we get our reverse shell. And now we can simply rickroll all day long. OK. So as you can guess, in order to exploit this issue, you need certain conditions. You need to have access to the server that contains the files, or you need to make client connect to your malicious host, which in this case you can also do this attack with combining it with some man-in-the-middle attacks. If you're on the same network with the client, with the victim, then you can simply force the victim to connect to your server with using man-in-the-middle attacks. And when you initiate these attacks, victim will see this warning on their side. This warning simply says remote host identification has changed because the differentiating public keys. And this warning can be ignored, or the client, if the client is connecting for the first time, they'll not see this. And if the victim ignores these warnings, you can simply get in between the SSH connection. So there are some tricks that you can do with Git repositories. You can also exploit this issue if the user is copying some files to a Git directory. You can simply add new Git hooks, such as pre or post commit hooks. And this can potentially lead to code execution, as you can guess. And there are also some tricks you can do to capture some IP addresses, DNS callbacks, with creating a specially crafted Git repository with a specific remote origin address. In this case, we're using a interact SH address. Once you create this Git repository, every command, such as git remote show origin or git fetch, will send a DNS callback. And you can potentially use this to capture IP addresses, capture locations of the victims. And this commands are automatically executed in certain softwares, such as some optimization themes and plugins, such as Git autofetch, automatically fetches the remote branch for showing you if you're behind of the branch or if you're above of the branch. Also there are other softwares such as LazyGit and some configurations of Visual Studio Code. Those make the user, if you go into that directory, then the user will simply send a DNS callback, and you can get the IP address and the location of the user, in theory. So let's talk about how to fix this. What are the possible mitigations? So as I said, this is a very fundamental issue. Everybody needs to be careful about where they're copying their files from. But there are some possible mitigations. In this case, for example, we know how many files to expect from the remote host. In this case, we are copying the etc passvd file to our local directory. So this is a single entity. We expect a single new directory entry on our destination directory. If you see an additional file, then it means there's something going on. And the client can easily check this. It's also valid for if you're copying a single directory. This is also a single entity. Then after this operation, you expect to see a etc directory. If you're seeing anything additional, then again. But if you put a slash at the end of your remote path, then things became complicated. The client has no way of knowing what's under the etc directory. There could always be some additional malicious files. So almost 1 month ago, we've reported this issue. But it's still exploitable, by the way. There's no current patch. We've sent a couple mails, but we couldn't get a reply. And I have to admit, we didn't pursue a very responsible disclosure in this case, because simply we were too busy. We had a very busy quarter. But after this presentation, I'll try to open up a GitHub issue for this. So be careful while using Rsync. It's still currently exploitable. This is the CVE we have reserved for this. And this was it. Thank you all for listening. If you have any questions, now's the time.
Boatload of money.
Any questions?
And they asked if I wanted to continue, and I go, no, I said, let the girls, because we were 75% women.
Does this vulnerability also exist in the Windows-based version for Rsync, or is it just Linux-based only?
Good question. I don't know, but possibly yes, because it's a cross-platform code base, I guess. It should be exploitable. We didn't try it, but be careful. Yeah.
You're buying it for a reason. You're buying
Any other question?
Yep, and they've lived up to it.
Yeah, you talk about mitigating for an added file
6 years in.
on the client side, but how do you mitigate for a file that has been changed?
Sorry, couldn't hear the last part.
A file that had been changed.
COVID was good.
You know, you presented you can change files on the client side. No. How do you mitigate that? Because
how do you mitigate what exactly?
When you change a file.
When I change the file. Okay, the mitigations I proposed was about specific cases. In this case, well, you don't see my slides. Can you put back up, please? Okay. In these cases, you're copying a single entity. So you, of course, expect to see one new entry to the destination directory. But this case, this is not exactly a vulnerability. There's nothing you can do about this. So SCP currently handles this situation just as I explained. It's controlling, it's globbing the incoming files. And probably this will be the mitigation for Rsync. I hope I could answer. Okay. Any other question? Okay, then. Thank you.